All right. Well, my name is Kira Kenny. I work as an environmental and ethical assessment advisor for Lendlease. So that means that my day-to-day includes doing life cycle assessments and embodied carbon analyses of major building projects and seeing how we can make them better for the environment. It's an area I've been interested in since I was a little girl. My dad works in solar power, and it's been my passion ever since. Anyways, today I'm going to give you a little bit of a background to embodied carbon in buildings and its relation to climate change and what we can do about it. All right, so first off, I'm going to start with a quiz for those of you at home. You don't have to answer, just, in your own rooms there. So the first question I have for you guys is, what do you think is the world's second most used material, right behind water from that list there?
Plastic?
Those of you at home who answered concrete, you are correct. In the time that it took you to do that little quiz, 19,000 bathtubs of concrete were poured around the world. So it's a material that we use a lot of, and it's quite damaging to the environment. So that was just a little precursor to what we're going to get into here. Now, this is a pie chart you've probably seen before. It's our global greenhouse gas emissions. And there's a lot of slices of this pie you're probably pretty familiar with. Transportation, electricity, agriculture, and even industrial processes. But the slice of the pie we're going to focus on today, and a slice that I don't think gets nearly enough attention, is manufacturing and construction. I mean, a lot of these things, they're more or less something that you can relate to as a consumer. I mean, transportation, you get into a car or on a train every day. Agriculture, I mean, we all eat food. Industrial processes, you're pretty more or less familiar with. But when's the last time you thought about construction and the way that impacts the environment? And if you look at a lot of these other slices, there are major movements around the world to change the way that we do things. There's a lot more research and development, a lot more funding, a lot more new companies opening up, a lot more young minds being drawn into these sectors. I mean, think of the strides that we've made in public transportation, in electric vehicles, in the transportation space, certainly in the energy space with the big push to get a number of different types of renewable energies out there to replace fossil fuels. Same with agriculture. There is a growing movement of people changing the way that we eat and interact with sustainable agricultural processes. But the manufacturing and construction slice of the pie is still not quite there yet in revolutionizing the way that we do things. And there's very little public awareness about the issue and what can even be done. One of the things that I find really interesting about buildings is that they're the background sets to our lives as the main actors. We work in buildings, we sleep in buildings, we're educated in buildings, but when's the last time you thought about the fact that the floor you walk across, the window that you look out of, the chair that you're sitting in right now, took an incredible amount of resources to get here. I mean, all of the building materials that are around you right now have their own complex international supply chain that had to come together to this one place at this one time to build this superstructure to serve its purpose. So while the embodied carbon that's captured in buildings isn't as, dramatic as smoke billowing from a smokestack, or as devastating and clear to see as a bushfire, it is something that is constantly around you all the time, hidden in plain sight. And that problem isn't really going to go anywhere. I mean, over the next 40 years, we are projected to build the equivalent of a new New York City every single month. And we have to. I mean, 2/3 of the world's population is going to be living in urban areas by 2050. We have no choice but to build. However, we do have a choice about how we build it. So just to clarify, when I'm talking about building life cycle, this is what I mean. So I mean everything from the moment that raw materials are dragged out of the earth and made into products. Those products are transported to site. It's then constructed into a building. That building uses energy and water, produces waste. It's maintained, it's repaired, it's refurbished. And eventually it reaches its end of life where it ceases to become a building and those materials go off to various waste streams. That is a building life cycle. And that's what we look at in a life cycle analysis. When I'm talking about embodied carbon, what that term means is all the building products and all their impacts upstream, the transport of those products, and the construction on site. So that's what you're used to seeing, the cranes, the excavators, all that sort of thing. Now, my second quiz question, what do you think of the embodied carbon phases is the most intensive? Is it the raw materials, and the manufacture, construction, transport? All right.
When they produce the Portland cement.
Yes, Portland cement is a major way of reducing embodied carbon, and that's because it's in the manufacturing phase. Manufacturing is the most intense of the embodied carbon of a building. So the interesting thing about embodied and why it's something that we're only really waking up to now is that all of those emissions happen all at once, right at the very beginning of that building life cycle. Operational energy is important, and it happens year on year on year. But it takes a number of years before the operational emissions even get close to the amount of intensity that you had in that embodied carbon phase. And all of those emissions are happening now in the make or break decade. So that is why it's so important that we focus on embodied carbon right now as we're growing the amount of buildings that we're producing. Now, when we're looking at material manufacture, where's the hot spots? Because there's so many materials included in a building, you have to start focusing on certain ones in order to make any sort of progress. The big three are almost always concrete, reinforcing, and facade. So that usually comes down to, in concrete, the most intensive part is the Portland cement. In the concrete, it's an ingredient of it. Reinforcing is mainly steel. And the facade, the aluminum in the facade has the majority of those emissions, followed by the glass and then the steel. Now, why is this such a difficult issue? Why is this such a hard chestnut to crack? Well, it's because of industrial heat. I mean, first off, those materials, there's not a whole lot of alternatives for them, and they work really well. And that's why we've been using them for, as long as we've been building buildings like this. Now, all of those materials take an incredible amount of continuous energy in order to create them, that industrial heat. They also produce a lot of emissions in their production process. And one of the unfortunate things about these industries is that renewables aren't really suited to a lot of these industrial processes. They need to be done at high temperatures. It needs to be a continuous and reliable amount of energy that has a high flux capacity. So looking at things like solar or wind, it's not really going to cut it. We're also looking at long-lived capital stock. If you're getting a blast furnace that's used for creating steel, that investment is for 60 years. It's very unlikely that you're going to, go back on that investment after spending so much money on it for a greener alternative just because you feel like it. Another thing is it's a globally traded commodity. So unlike electricity, which is all regional, these have razor thin margins on them. So if you are an aluminum company and you decide, hey, I want to make better aluminum, that's going to come at a cost premium, and then you lose a bit of that capital share, which makes it difficult. Also, a lot of governments, even progressive environmental ones, they often protect these sectors from carbon pricing because they're seen as important for national security and all that sort of stuff. So it is a difficult problem, but we're not going to dwell there too long. I want to move on to some technological solutions. So there was a report done by the Innovation for Cooler Forum. I've got a link to it at the end of this presentation. You can look at it. It's all in industrial heat, and they bring up some of the most viable technological solutions to industrial heat as a problem. The number one they suggest is hydrogen. So hydrogen, when combusted, can produce an extraordinary amount of heat that's suitable for these processes. Caveat, as with everything, you do have to think about the type of hydrogen that you have. There's three main types. So there's green hydrogen, which is hydrogen that's created with renewable energy through electrolysis, which is awesome. So it's very, very low emission, and you're replacing other types of alternatives. So it's great. There's blue hydrogen, which uses, so it's the same, it uses carbon capture, use, and storage. So there is CO2 that's produced through the process of making the hydrogen. However, it captures it and then it is stored for later use. I'll get into that a little bit later. And then the last one is gray hydrogen, which is the most common one and the cheapest one. And that is using steam to break down other chemicals to create that hydrogen. It does release a lot of CO2 as part of the process, but it's better than some of the alternatives. So hydrogen is still a pretty good deal overall. And then there are some renewables that work in certain situations for industrial heating. One of them is nuclear. It does fit the requirements of being able to deliver that high temperature at a consistent and reliable capacity that needs to. However, there are a lot of other surrounding issues with nuclear and a lot of politics surrounding it. So I want to open that can of worms right here, but it is one possible situation for these particular sectors. Another one is biomass. So biomass actually produces a surprising amount of heat when it's burned. The main issue with this one, of course, would be the supply, but it does work in certain situations in certain regions. CSP is concentrated solar power. Again, for certain geographical regions, concentrated solar power would be able to produce the amount of reliable and constant power needed for these processes. So CCUS stands for carbon capture, use, and storage. So I touched on that before with the blue hydrogen. So this is basically taking processes that produce a lot of CO2, say a blast furnace takes coke, combusts coke in order to turn the iron ore into steel, and that produces a lot of CO2 in that process. Making aluminum, you've got aluminum oxide with a carbon cathode that's molten. That creates a lot of CO2 as well. So capturing the CO2 from these processes that's directly emitted and then using it for other commercial uses. So there are other commercial uses that require CO2 as an input to their process. So taking that from there and moving it somewhere else does help reduce the emissions a little bit. Doesn't completely solve the problem, but it's a step in the right direction. Electrification, this is mainly when talking about steel. So of that, whatever, 12% carbon emissions, a good chunk of that is actually from steel. I think it's 5% from concrete and 7 to 8, depending on where you get your number from steel. And so moving away from a blast furnace lag, as I'd mentioned, where you're combusting that coke, moving to electric arc furnaces that generally uses recycled steel is actually a much greener process than some of the traditional methods. Geopolymer concrete. So concrete has stayed the same forever. It really, really has. We haven't made a lot of adjustments to it. One thing you can do at the moment is reduce Portland cement, which is, again, a step in the right direction, but not completely there. Geopolymer uses a completely different binding agent for the concrete. So you're getting rid of that really intensive ingredient altogether, which is awesome. It's not quite commercially viable yet to use in all circumstances the way that concrete is today. At the moment, it's mainly for precast. So technology is getting there, but again, at least it's a solution for some concrete applications, which is good. And CLT stands for cross-laminated timber, and it is by far one of my favorite building products up and coming today. I actually have a little bit about cross-laminated timber coming up later in the presentation, so I'll save it for then. But basically, it's these, timber is a great material. It's one that we've been using forever. The main limitation to date was that you couldn't create these larger structures with it, but what cross-laminated timber does is it takes that timber and glues it together at 90-degree angle to each other so that it has a lot more strength and you're able to build bigger structures with it, which is really exciting. So it's an actual alternative to concrete, which is cool. All right, and stone. So there is a current prototype out there for going back to quite an ancient material and using sort of like it's a little bit like a precast, like reinforced stone. So that's another option as well. I wanted to talk a little bit about this issue post COVID-19, because I feel like there is this sort of air of uncertainty around what's going to happen to all of this momentum that we've created in a lot of different environmental issues after COVID-19, because all of a sudden, you know, it put a brake on a lot of things that was happening and gaining momentum. 2020 was supposed to be this super year where there was international meetings on biodiversity and oceans. COP26 for the Paris Agreement was supposed to happen later this year, and that's all those meetings are up in the air now. Plus, you know, you're not seeing protests or anything like that anymore, certainly. But I've seen this image circulated a lot, and I think it's a sentiment that's shared by a lot of people, of flattening this curve too. And I think the reason why I've seen this circulated so much is because this is an almost unprecedented time in human history where we have this collective global consciousness. One of the few times where we have really come together as a globe to fight a singular issue. And everyone's going through similar experiences, no matter where you're living. I mean, some worse off than others for sure, but I think that collective consciousness is definitely going to help post-COVID-19 in creating a second collective consciousness that is definitely needed to tackle climate change. So hopefully, just as we will all come together to tackle COVID-19, we will all come together to tackle another great risk to everyone, and that is climate change. You are seeing some silver linings in this crisis as well, such as emissions going down, animals returning to places we haven't seen for a while. It's almost like a collective breath for all of us and for the environment. And one really interesting thing that happened to me recently, which I thought I'd share, is that I had my very first online conference. So the Transform conference is one that happens every year with the Green Building Council Australia. They moved it online, and all of their videos and all the talks that were held in that conference is on YouTube, so you can access it. One talk that I thought was particularly encouraging was from Martin Wilder. He's from ARENA, which is the Australian Renewable Energy Agency, and he was talking about climate change and TCFD. So TCFD, for those of you who haven't heard it, is the Task Force of Climate-Related Disclosure. And that was basically created by the World Economic Forum in response to the fact that you had all of these insurance companies and investors who were like, we really, really need to know the risk that our assets are at because of climate change. And it sort of flooded the market with all of this information from a number of companies. And long story short is his sentiments, and this sentiment was echoed throughout the entire conference again and again by a number of industry leaders, is that COVID will have impacts for a while. That's without a doubt. But a lot of these climate movements that have been put into place is for the long term. A lot of economic agencies and investments and super funds, they care about the long term, and the climate change issue is not going anywhere, and it is something that will have equal weight after COVID-19, and it's something that we can't afford to not to lose focus on, basically. So that was an encouraging message, and again, I encourage you to listen to some of the videos from that day. It was great. And now I'm going to share some good news, because it can be really depressing thinking about, you know, this industrial heat issue and all of these buildings that are going up, and oh my God, what are we going to do about it? So I thought I'd share just a couple little tidbits of good news. I could share more than this, but just a few to brighten your day and to, you know, let you know we're heading in the right direction. So ThyssenKrupp. So this is a German steelmaking company. They're really, really big, and they did something awesome. Okay, it was proved in theory, but it's the first actual pilot in the world to take off, and that is the fact that they have a hydrogen-powered steel plant. Again, I've got a link at the end of the presentation. This is a game changer for the industry, and it was something that was told would be too hard and not economically viable, and they made it happen. So hats off to them. That's pretty cool. This fine man here is Sanjeev Gupta. He is the CEO of Liberty Steel. They announced last year that they're going to go carbon neutral by 2030, which is absolutely awesome. A big part of that is moving to electric arc furnaces and such. Skanska is another construction developer. They had a really cool target by 2045, which is becoming carbon neutral all throughout its supply chain. So that's scope 1, 2, and 3, which is a really big endeavor. Lendlease is heading in the same direction as well. We haven't officially announced our target yet, so I can't tell you, but it's heading in that direction. One of the things I think you should look out for when you're looking at these claims is the extent and the scope of carbon neutral claims. So something like scope 1 would just include the direct burning of fuels, like, I don't know, diesel excavators on site or something. Scope 2 would be something like the electricity that you consume. And then scope 3 is your entire supply chain. So all the emissions all the way back for every piece of material that's in it, which is just, it's pretty cool. ELYSIS. So this is a low carbon aluminum, much lower than the average one. And this uses inert anode technology. So as I mentioned, the smelting process for aluminum ingot is really, really intensive. And another thing that's very difficult about it is that it's not your supply chain, it's your supply chain. So it's not the actual aluminum frame in your facade that'll be the difficult part, it's the ingot before it. So having that sort of influence is really difficult. So having these types of products available is great. It does come at a cost premium, but it is growing with a little bit more popularity. Apple has backed it as its aluminum, which is massive because they use so much aluminum in their supply chain. So the fact that they're pursuing this is, it is a game changer, and it is industry leading, and it's very, very hopeful in my opinion. World Building Council. So this, a lot of countries have their own Green Building Council. The US has one, UK, Australia has the Green Building Council Australia. And basically a lot of green certifications that buildings go through certification schemes through these building councils. And the World Green Building Council releases a report bringing embodied carbon up front and recognize that one of the biggest issues that the construction industry is going to be facing is embodied carbon. It is time that all of these certification schemes truly reflected it and pushed the boundaries on what buildings have to do in order to get that certification, which I think is just such a good step in the right direction. And I'm very excited about that. There are some major companies that are actually putting some very tangible sustainability goals out there. I think you see some companies that are putting sort of wishy-washy ones. A really good example is Microsoft. So they want to be carbon negative by 2030, which is massive. That includes, all of their operational emissions, but also their supply chain emissions. I mean, that's the blue bar there. I mean, look how big their supply chain emissions are compared to their operational. Not only that, what they want to go carbon negative, where they're actually actively removing carbon from the atmosphere. And they're doing this all the way back to their 1975 operations. So that's a very holistic, very exciting target, and I hope to see more companies follow suit. Jeff Bezos, the man in person. So Amazon has announced a carbon neutral target by 2040. They've donated $10 billion towards climate change initiatives, and they're looking at this as a major investment opportunity as well. So for example, they wanted their fleet to be all electric cars doing deliveries in the US. So they actually invested in a company that made electric vehicles and bought 100,000 of them. So that's pretty cool. Richard Branson, so he wants to, so an entrepreneur's sort of take on this whole thing is creating a clean energy dividend, where instead of a tax, companies based on their emissions, a certain percentage of their profits would have to be invested in renewable energy. And then, when those investments sort of dry out, then going towards other environmental initiatives. So the interesting thing behind this is, instead of it being a tax that goes to the government, it's something that companies could see as an actual investment that might create a return for them. So that's just another take on the problem, which I thought was interesting. MIT have, in a lab at least, created this emissions-free cement. It's magnesium oxide cement produced by an electrolyzer. Now, it's not quite ready to be commercially viable, but at least, it's some research that's going into it. And again, this industry doesn't have a lot of technological research going into it, so it is pretty cool that that's coming out. And then I just want to talk about some progress made. So those are all things that are kind of happening in the future and emerging. And I want to give you some examples of what a sustainable building precinct would be doing at the moment. So I'm going to talk about Barangaroo, just because I know it's a precinct I know a lot more about because Lendlease built it, and some of the things that we did there. So Barangaroo is one of Australia's first carbon neutral precinct in operation, which is awesome. And every single works package within Barangaroo had to reach a 20% embodied carbon target, which was pretty big, especially at the time that it was set. And it meant that every single building had to actively work towards reducing its emissions. Some of the main things we did first, obviously, was we focused on concrete. So all of the cement in Barangaroo reached a 40% cement reduction on average. Some of the mixes got up to 60% reduction, which is great, and showing that that was something that was viable. Another thing we did was a preferential sourcing for our steel, making sure that it was sourced from some of the lowest emitting mills that we could. And then another exciting thing was we worked with the facade engineers on the towers there to reduce the amount of materials that were used in the facade. Like, I don't know if you've ever walked through there and you've been up close and you can see the crazy fins on there. So we worked with them to see how could we use less aluminum, glass, and steel in that process. So that was pretty exciting and groundbreaking at the time. And then we also did a life cycle assessment and looked at what are the top 20 materials that we need to look at. What are our biggest concern? If we are looking at sourcing better materials, where do we start? And there's a ton of examples of that, but one that I found really interesting was the access floors. So access floors are like, you know, you walk across them in most offices and you don't even know that they're there. It's just like a raised floor, so they can put all the wiring and stuff beneath. And they actually are often made out of cement or steel, and they can be quite intensive. So we went out to the market and said, we want a carbon neutral access floor. And it didn't really exist yet, but the subcontractor that we assigned said, we'll make it happen. So that subcontractor that made access floors looked at their entire supply chain, their entire process. They then, after they measured it, they reduced their emissions. And then they created an environmental product declaration, which is amazing. It's like this international environmental nutrition label, if you will. And they're really, really useful in our line of work. And then they made themselves carbon neutral. So to see that influence that we had as a company where we went out to the market and we're able to say, we want this to happen if someone can make it happen for us. And in response, we were able to see that come back is really a testament to how influential a larger company can be in creating the change that they want to see. Yeah, I think that's enough on that now. I do want to talk about one building, which is my favorite. Actually, there's two of them. And these are the cross-laminated timber buildings. So as I had mentioned, the cross-laminated timber is this up-and-coming material that could potentially replace concrete in some applications. So it is that timber that is cross-laminated and glued together. At the moment, it's you can make you know, low to mid-rise buildings out of it. We haven't quite cracked being able to do high rises out of it, but I think that's something that'll just emerge as we become, as we work with the material more. Concrete has had, you know, 100-year plus head start, so, you know, we'll give CLT a break. But one of the exciting things about these buildings is that they are prefabricated, so the construction is faster. It's a lot safer. The amount of people that it would usually take to create a building like this would be about 200. And this building was created with a crew of about 12. So, and it was a lot safer than concrete as well. So it's just, from a logistics point of view, it was a dream. Actually being inside the building is really, really good for the occupants as well. So once you're inside, the acoustics are amazing, so you don't get reverberation or anything like that. Great thermal properties, so it's able to operate with optimum energy efficiency. The indoor environmental air quality is better. And because you're expressing that beautiful timber, you're actually reducing the amount of materials that you need, A, because you don't necessarily need a ceiling. You know, it's got all the exposed surfaces there. And B, having people exposed to that wood actually has biophilic benefits. So it reduces the cortisol, which is a stress hormone in your system, reduces your heart rate, reduces blood pressure. It's all in all better for the occupants. And the environmental impacts of this timber compared to concrete is miles better. It's also, because it's a natural material, does sequester carbon within the wood naturally, which is really great. Yes, that's all I had that. Oh, and also, all the buildings in Barangaroo are pursuing green certifications. The towers received 6-star Green Star certification across the board, which is the highest that you can get. Platinum WELL certification, which again is the highest that you can get, and that cares about the well-being of the occupants inside. So, you know, low VOC materials and all that jazz. And yeah, I feel like there was something else. But yeah, there's tons of sustainability ratings. We've got recycled water treatment plant, rainwater capture, recycled black water, all sorts of things. So I go on all day about that, but I don't want to bore you too much. Point is, there's loads of things that we can do to make sustainable precincts. And we were able to make it carbon neutral, which is awesome. Okay, now one last thing before I lose you completely, but I just wanted to talk about where the building industry is going and where it's going in a circular economy point of view. So there's this really interesting concept, and an example of this is Park 2020 in Amsterdam, where instead of building a building where you own the building, what if you didn't own those materials, but instead you leased them? If everything was made modular, if you were only borrowing those materials and you knew, okay, I only really want it for 20 years. And after that, my needs are going to change, or the needs of the city are going to change, or I want it to look different. So you're renting those materials and then giving it back to the supplier at end of life. The supplier is able to recycle those materials. There's a much, much higher recycling rate at the end of life compared to what it is now, because a lot of materials are harder to break apart, and it depends on the recycling infrastructure of the country that it's done in. So this whole concept of only borrowing those materials and using it for what it needs to be used for in the time period and then giving it back is absolutely revolutionary. And it is something that we're moving closer and closer towards. That is probably one of the most promising ways of looking at how we do buildings in the future. And where do we go from here? So as was mentioned early on in the presentation, a price on carbon is probably one of the most influential things, and it's a big umbrella that will have a lot of positive influences. And then, of course, having investment in research and development so we can look at better materials to use than the same old ones that we've been using forever. Engagement across your supply chain and responsible procurement. I mean, look, all a building is, at the end of the day, is a sum of decisions. A bunch of people have come together to make those decisions about that building. So really looking at each one of those decisions carefully and at our supply chain is absolutely paramount in order to create the change that we need. Fiscal subsidies is also going to be really important. Green rating tools, so again, the World Building Council sort of creating that. And embodied carbon targets. I mean, I can't tell you how influential in the outcome of Barangaroo those embodied carbon targets were in reducing our overall impacts. And one last note, everyone here listening to this at the moment, most of you probably don't work in the building industry. So what can you do? The most important thing that you can do as an individual is to talk about it. I mean, this is such a massive issue that just, there isn't enough awareness on. I mean, if we want people to do something about it, they need to know about it first. And that's one of the reasons why I enjoy doing these talks. And that's one of the reasons why I'm so excited to see so many of you on here today listening. If you do anything today after this talk, you know, share it, talk to a family member about it, just to sort of get that level of awareness around. I mean, there was one video of a turtle with a straw, you know, up its nose, and all of a sudden, overnight, no plastic straws. I mean, think about that. If we could get people outraged on the street about concrete and steel and demanding change, that is what I want to see. And I would be so excited if we, in some small way, were part of that. So that's most of what I had for you today. I have a ton of useful links with all sorts of information in a variety of topics, mostly around this, but I've also included a podcast that I really like called Outrage and Optimism, and a few other, anyways, look at the links, they're great. And that's my LinkedIn if anybody ever wants to contact me. I could see a lot of chats coming up here, so I'm just gonna stop sharing. Okay, and yeah, cool, are these questions? How can we apply a suite of settings to reduce the reliance of people in regional areas relying on wood stoves and heating? Can you have double glazing while still reducing your facade footprint? Yeah, well, the thing is you have to, I think about double glazing is it is important because you need to reduce the operational energy of your building as well. The interesting thing about life cycle assessment is that you don't look at one stage of the life cycle. You try to look at the entire thing, and you do look at the trade-offs between those different areas. So yes, I want the double glazing because it'll reduce the amount of energy that you use. But could we, play around with the thickness? Can we play around with where we get it from? And again, if we were really going to reduce the impacts of the facade, I'd probably start with the aluminum. So doing, testing to see if there's different modules that we can do, different designs that we can do that would reduce the amount of aluminum in the facade. Be really good first stop.
We'll take a question from Peter and Paula in Western Australia about local councils.
Yeah. Is there a report that we can share with our local councils? I've included a lot of information in the links at the end. I'm trying to think of which one would be the most influential, because the thing about these reports is you do want to find one that is as short and sweet and clear as possible. The ICEF one is probably the best, but it's very technical. World either Architecture 2030 or the World Green Building Council bringing embodied carbon up front, I think are some of the probably the easier and best ones to share. Again, those links are in there, but yeah, those are the two.
And would I be able to ask a question / give some of my own opinion? So yeah, I'm Nick. I'm actually a structural engineer. Hi. So a lot of the stuff that you're talking about, not necessarily into the whole materials properties, but it is interesting because the supplementary cementitious materials that have been replacing Portland cement and those ingredients are like fly ash, but that's a byproduct of coal fire plants. Yep. So that is one big issue that they've got to come up with now, is how do we keep producing concrete when we can't make these savings? I think with sand as well, that's still quite another one. With geopolymers, I have never seen a geopolymer be designed, or a geopolymer sort of concrete replacement. And it's sort of like what you said, that it's really good in controlled environments, but concrete is very predictable, even with slight changes to the initial conditions, as in geopolymers have quite a big problem where you can go, if you set it up and then you get a certain result. But if you change a few of those, and all of a sudden it goes from working to just failing, which we as design engineers definitely don't like signing off of. And in Australia, this is probably just generally to the whole council, what's really difficult is we're very much what we call like FRP, formwork, reo, poor. So you have these three major, and like the CFMU is one of the biggest unions in Australia. So while timber, and I'm actually designing a timber CLT building, and I've looked at that. Yeah, I've looked at that building, that one there. I actually work on the Crown Casino as well, directly next to.
I've worked on that project too. Funny. Okay.
Yeah. So yeah, so I've worked on that for the past 4.5 years. But when I'm doing like a timber building, and what's probably makes sense at a logical level, or let's use timber, the ramifications for that across those unions are going to be massive. And we might not be able to build as high, like timber. I don't know if you can go super high rise at the moment. Obviously, with concrete, we use post tensioning, and that thins out your concrete. And there's all these. A few other things, but yeah, the biggest problem is to change the way that they actually build is going to affect so many thousands of people. Like so many people, like, if I'm going out on site and it's concrete and rare, there's 3 or 4 trades, and each one of those trades could have 10 people. And I understand that timber is it's actually easier for us to design because it's all built in a shop, and they bring it to site and they screw it together. So there's less variability in that. But that's the biggest problem from an actual policy level. So where do you make this decision? Like where is it? You got to get the developer before he does it. And when we talk about looking at designs and iterating designs, there's another issue, and this for me personally is a design engineer we're not gonna redesign it 4 times to get paid once. Like we're just not gonna do that. So there's all these little, I don't know, let's just say realistic issues. Obviously, I'm confident that we can hopefully solve them. But yeah, that's just some of my thoughts.
Yeah.
I'll just jump in because there's a few other questions coming up. With CCL's proposal, of course, is to put a price on carbon, which would mean concrete made with burning oil would become more expensive. That would give the incentive to drive the transition. So that's, you know, these things are going to take a lot of work, and that won't happen unless there's an economic incentive to go to other technologies. And so we won't get involved in any more detail. There's a couple more questions that Tim Min wanted to ask a question on nuclear, and Ian Bryce is jumping up and down because he's got a question he wants to ask. And in terms of the more general questions, this chat can continue in CCL's pages. So 2 more questions we've got time for. Tim, and then Ian Bryce.
Okay, thank you. Very good to hear all that information. Thank you. What concerns me is that when you put in a proposal to do some activity, you have to report which side of the road the pedestrians are going to walk on and how you're going to control the traffic, but you don't have to say how much carbon dioxide it will liberate, as far as I know. When are we going to introduce a simple requirement that if you put in a proposal to demolish a stadium and build a new one, you have to say how many million tons of carbon dioxide will be liberated?
Ian, I think we got the point. We'll take that as a comment. You're sort of making a point that all the decisions made aren't in the best interest. And Tim, your question?
I got a question about the nuclear technology option that I saw on the screen. How could that be the good option? What are the pros and cons of the nuclear technology in terms of the current technology and the future technology that can be beneficial to the environment? Yeah.
Well, look, I'm not an expert on nuclear technology. I just know that it produces far less emissions than a lot of other potential energies out there, and there is a bit of debate about the waste and how safe it is. But I mean, historically speaking, it actually is a really, despite public opinion, it actually really is a very safe energy source, especially some of the second generation nuclear reactors that are being created. Where a lot of the issues from previous designs have been removed. And there's a lot of safer ways to deal with waste as well now. So like, again, not a nuclear expert, but I do think it is something that is becoming more viable. I think the main thing standing in the way of nuclear energy is the cost and also public opinion. But that's just me, that's my 2 cents. Also, Nick, to answer some of the things that you were addressing, I do think one of the challenges is when we get involved as well. So we do like to ensure that our team is involved as early as possible, like as, very, very early concept stage, as specifications are getting written, and making sure that we have greater sustainability policies being involved in the project from the get-go, and they're from like a greater sustainability framework, so that infiltrates down to a project level. So you don't have people, having designed 4 times because we've decided from the get-go, this is what we're going to do. This is the caliber of work that we do and the standard to which our environmental initiatives are. And you're doing a 40% cement replacement and that's it. Or you're doing, this and that's it. As far as the jobs, just want to say, just like any transition in the environmental space, I think that there needs to be support for people that are transitioning industries, but in the same way that computers came along and took away a lot of jobs, there was a lot of new jobs created. And I think that the construction industry will be slow, it will not be painless, but it is something that does need to happen. And hopefully the increase in research and development in this field will be able to come up with solutions that will be able to take all of those different considerations into effects, because nothing happens in a vacuum, right? It is definitely something that does need to be addressed as we make these progressions.